All right, geometry for 4.4. And I know it says 4.5 here, but 4.4, we're going to prove triangles congruent using two more ideas. The ASA and the AAS postulates. So for these two, you guys, notice again, just like the last lesson, that the A is standing for angle, the S is standing for side, and that the order is important. Okay, so an angle and then a side. This would be a side in between two known angles, right? If we know that is congruent within two triangles, then we know the triangles are congruent. Or if we know two angles followed by a side is congruent, then we know two triangles are congruent. So this is going to wrap up all the possibilities, and I'll give you a nice summary sheet of this at the very end of this. But today's lesson is, a little in depth, but pretty short. So here we go. Let's start with it. The very first thing, get this in your notes, the ASA congruence. What this states, and the picture is probably the most important thing here, is that if two angles and the included side, okay, so let's be clear here. We have two angles and the side in between, okay? If those are locked into place, notice that if the angles are locked into place with that side length, then, and I can show you this in class as well, then I know that the rest of the triangle has to be locked in place as well, because we know that the third angle would have to be congruent, and then if we know that this side length is congruent with another triangle, then these sides would have to be the same as well, because it's all locked in place. Okay, so if two angles in the included side of one triangle are congruent to two angles in the included side of another, then the triangles are congruent. Okay, so this is known as the ASA congruence. So today in your proofs, when you make a proof for this, you're going to try to prove that you have two angles that are congruent and the side in between them is congruent. And if that is the case, then by ASA we know that both triangles are congruent. All right. So let's try one of these. For example, one here. So it says given that ZX, so let's write this in, ZX bisects angle WZY, and that XZ bisects angle YXW. That's what's given. And then we're trying to prove here that triangle WXZ is congruent to triangle XZY. All right, so let's just make a picture of what's going on here. If ZX bisects WZY, okay, so WZY, if you trace that out, that's this angle right here, okay? So if it bisects that angle, even though it doesn't look like it, this angle here is congruent to this angle here. Definition of a bisector, which we're going to write down here in a minute. And then we also know that XZ bisects YXW, which if we switch colors here, let's switch to green. If we trace that, that's this angle, right? So what that's saying is that this is congruent to this, even though, again, it may not look like it. This is telling us that it is. All right. So the very first thing is we need to use our definition of a bisector to show that those things are congruent, right? So let's do that. We could do it both on the same line here. So let's say that angle WZX is congruent to angle YZX. And we can also say that angle, so those were these two, right? We can also say that angle YXZ is congruent to angle WXZ. All right, and that's because of what we just pointed out, right? I'm just stating that. And the reason for that is the definition of a bisector. Okay, so I know these angles. And now what I need, if I'm going to use ASA, is I need to know the side length in between those angles. So here we'll use 2 marks on this one mark on the other. The side that's in between would be this side right here. I need to prove that that's congruent. So to do that, I'm just going to say side ZX is congruent to side ZX, And since it's the same exact line that we're talking about, which again, in yellow, is this line right here, right? Both triangles share it. It's in between the angles that we know are congruent. So what we can say is, by reflexive property, those two things are congruent. ZX is congruent to itself. Okay, now we know that the two triangles are congruent, and the reason for that is the ASA postulate. All right, so ASA, an angle, side, angle. Let's look at another idea here. This is angle, angle, side. So notice the picture. The picture is important. We have an angle, and a side length in that order. Angle, angle, side. Okay, angle, angle, side. If we know that an angle, angle, side is congruent in two triangles, then we know that the two triangles are congruent. That's what this is saying. So you can pause the video here, make sure you get that into your notes. I would definitely draw the picture so you can see what this is talking about. And when you reflect on this in your notes later, and let's use it right away in example 2. So here we're going to use AAS to prove congruence. All right, and it says to write a flow proof. We're just going to write a 2-column proof, which I gave you in your notes. Okay, so let's do this. The given piece is that RQ, side RQ is congruent to side ST. And they also told us that RQ is parallel to ST. Okay, so that's given. And then they mark that for us, which is nice. Okay, now what we need to do is work on, if we're going to use AAS, which you won't know in the homework which one you're going to use, so you're just trying to find angles and sides that you can say are congruent here. Okay, so the first thing we're going to do, and one thing I want to highlight here, and I will highlight this, if RQ is parallel to ST, then any of your parallel rules can come into play here. So all the rules that we studied when we studied parallels and the relationship between transversals between parallels, that's going to come into play, right? So you're going to go back to your toolbox for that. But first of all, let's do something that we should be very comfortable with now. If you have two lines that cross, any two lines that cross, remember that they create these congruent angles. Those are called vertical angles, right? So if you look at our picture here, notice we have that, right? Right here, we have two lines crossing. So we can say that angle SUT is congruent to RUQ. RUQ, okay? And the reason for that is the vertical angles theorem. Okay, so we now know that. So we have an angle and we have a side length. So we're either looking for another side length someplace or looking for another angle. So let's see if we can figure that out. If these lines are parallel, and I'm going to go ahead and erase what I put there. If these lines are truly parallel, okay, they go on forever, right? We could assume that even though in the picture they don't, right? They're parallel. And then notice that this parallel lines are cut by this transversal here. Okay, so if that's the case, we should be able to say something about this. Notice here we have this angle on one side of the transversal, which is this guy, this one on the other side of the transversal, but in between the parallel lines, right? We know that those are called alternate interior angles. Okay, so that's a reminder from a previous lesson. Those are called alternate interior angles. And we can only say that those are congruent because these lines are parallel. Okay, so we're using that postulate there. Alternate interior angles are congruent. All right, so we could have done that the other way as well. So in another color here, I'll show you what that would look like. We could have used this one. And again, we could have said the same thing with these two, but I'm not going to use that. I'm going to use the other one. But you can say both. But we only need one. We only need one to prove that these two are congruent. So we're going to use this one. So here we go. We could say that angle UST is congruent to angle U. Let me just make sure this is a Q. Yeah, angle Q. UQR, angle UQR. Okay, and the reason that we can say that is the alternate interior angles are congruent. Okay, we're going back to our parallel postulates. Okay, so you can just abbreviate it that way. So now that we know this, we know that this is congruent to this, right, in the middle, and then so we have two angles and we have a side. So we can now say that triangle RUQ, sorry, I should have put this down in the very beginning. I think I said it, but we didn't talk about it. We're trying to prove the two triangles are congruent. Okay, and the reason for their congruence is angle, angle, side. So there, now we've used it in another example. And here's the final summary, you guys. So these are the 4 ways that you can prove triangles are congruent. Okay, so you can either show that 3 sides are the same, a side, angle, side in that order is the same, an angle, side, angle, or an angle, angle, side. All right. Notice there is no angle, side, side in geometry. Okay, there is no angle, side, side in geometry. So do not try to prove something that way. I guess I could have also written that a little different, SSA as well, right? So that these 2 cases are not ways to prove that 2 triangles are congruent. Don't try to use that. Okay, so that's the final summary there. And remember, just a reminder, the CPCTC, if you're trying to prove that 2 angles or 2 sides are congruent after you've shown that 2 triangles are congruent, you would use CPCTC. Okay, so this is, you never use this to prove 2 triangles are congruent. Okay, but if you know 2 triangles are congruent, you would use this to prove that any of their parts are congruent. And then one last thing, the reflexive property. If 2 triangles share a side, we know that that side is congruent to itself, which we showed earlier in the proof. That's it for now, guys. The homework, you have a homework sheet, and we'll see you guys next time.